Hi everyone, welcome back to Dragonfly Engineering. So this week we're finally going to finish the tabletop for the robot work cell, and we're going to drill the 800 or so holes into the top of it, and we're going to use Big Yellow, the Kuka robot next door. And my wife April here is going to help me out with converting the G code for the milling machines that I normally write into a Kuka code that Big Yellow can understand. So would you like to show us how you do it?
Sure. Yeah, like Dave was saying, we're going to take G code and we're going to convert it into Kuka code. And I'm going to do that using Python. And on this screen, the left-hand side is the raw Python script, and on the right-hand side is the terminal mode. So what I first do is I ask the user to confirm the tool angles and confirm the Z heights. And then I go and I find the G code file, and then I intake it. And then after it's brought into the Python program, it is parsed and dissected and digested, and then I use a set of rules and I make a data frame. After the data frame is made, I take a known header and a known footer, and then I take the data frame information and then I build out Kuka code. And then that whole segment is saved into a file and saved onto the C drive of this computer. Okay, so let's get a live demo going here. So I'm activating my Python script here. It's asking me, what file are you trying to convert today? I'm going to type in my file name. Now it's going to go through and ask me to confirm the tool angles. Yes, I like all the presets. This is the G code that's coming in from the file. This is the data frame that it parsed through from the G code. Done means I have saved the file of Kuka code. So, back to you, Dave.
Oh, thank you. All right, well, let's try it out over on the robot. All right, so now what we need to do is basically square the tool up to our tabletop. In a previous episode, we defined the length of the tool, and we used the length of the tool to then define the location of the tabletop. But now what we want to do is drill straight perpendicular holes. And to do that, we need to figure out what the angle of this plate that mounts the electrical hand drill in is, or find out what the angles are such that this plate is parallel with our surface to drill, which would result in a perpendicular drill bit. So we'll do Y first. You can't see the bottom features of this plate, but I did this plate in another episode as well, a previous one. So here you can see we're moving. And this indicator is in inches, so we moved, we had a walk-off on the angle of this plate of negative 10, 20, 35 thousandths. So I'm going to do an iterative process to basically bring this needle to some probably location between 0 and our final, and repeat this until we have a square plate. So I think we're good on that. I'm going to record these ABC angles so that we're good to go when we program the toolpath. I don't want this paint to start rubbing and gouging the plate of our table. So I had to find the angle, the 143 minus 143 degrees, which currently the angle is plus 163 degrees. So if we move back to the angle that I was talking about, the wrist will flatten out and be in a clear orientation, or stay above the actual plane of drilling that we're interested in. So right there, that's 140, basically 140 degrees. So that's kind of important that we don't crash part of the robot into the table. So little details like that you got to be aware of with these 6-axis robots. Okay, let's get our drill center and loaded up in this drill chuck here. We are going to drill the mounting holes for the 4 robot locations on the 4 corners of the table. And these locations are not going to be locked into the coordinate system necessarily of the grid array that we're going to drill into the table, which is referenced from the 0 that the robot's at right now. But these holes in the corners are actually drilled using the center of the weldment with the thread that's threaded into the steel frame weldment underneath this table. And that was, you know, a weldment done on the floor without like fixtures per se. So these 4 sets of corner holes that the robots are going to mount to probably do float around by maybe a millimeter or 2 relative to the actual 0 of the table itself. And this table was just, you know, panel sawed at the metal manufacturer. I didn't go in and machine it to an exact shape or anything. So I think basically we're just going to, using the robot, manually drill these hole locations. So I'm going to find the center of this hole, probably visually, and then come over and drill the other 3 holes, which are going to be through holes to mount the robots. And we're going to do that in all 4 corners. I've actually done it in this corner already, but the remaining 3 corners, we will make the robot mounts relative to their local hand-drilled holes. So we're going to jog the robot drill tip over, and I'm going to probably manually find the center of our hand-drilled hole over there. And this electric hand drill doesn't really spin that fast either. So that's something else that I'm going to have to deal with. I'll have to slow down the feed rate for drilling. So I'm just going to plunge this center drill, outside diameter, into our hole. There's some decent slop in the mounting of the robot bolting flange to the table anyway. Of course, I get the direction backwards every time. Okay, 1020. I did put a rough Sharpie marker target on the table just to make sure that we're good. Okay. Okay, so now we can drill out with our approximately 10 millimeter diameter drill bit. We'll see if we can do this in one pass since we did the center drill locations. And hopefully I've got enough weight on this table where it doesn't flop around too much on me. I think I may re-bolt this corner down since we're done finding the locations. And again, this is all kind of manual machining using this Kuka arm. Okay, because I was seeing a little bit of table wobble, but some of that just could be that I don't have this corner bolted down completely. So let's see if we can stabilize. I've got about 300 pounds of extra bags of plastic and other packages on the bottom rung of this stainless steel frame, or this welded steel frame, and that's helping to dampen out any side loads from drilling. So this drill bit may actually have a decent amount of side load, but we'll find out right now. So let's try it out. Oh. I don't know if the drill like that. Hey, this robot's a little too powerful. Oh, I see. It pushed out of the clamp a little bit. I think I exceeded my clamp force. I got to tighten down the jack screw here. So what happens is the hand drill actually pushed up out of its clamp, which is kind of a safety mechanism I did, and which also released some of the force on the trigger, the variable speed trigger. So I will reset and tighten this thing down. Okay, so let's loosen our little clamp here. Reset the drill so we fully engage the trigger. It's kind of like an auto shutoff, I guess, that I serendipitously made. When the drill slips out of its radial clamp, then the trigger stops. But that doesn't necessarily stop the robot from keep pushing, but ultimately the drill will just fall out of its clamp completely. Okay, we'll retighten this down. I may actually put a set screw in there to set screw into the cast aluminum body of this hand drill. But I kind of like the safety limit or the force limit that we're creating as well. So it's hard to say what's best. With this cast aluminum, we don't really need to peg too much because it's pretty good at clearing chips. Now I am going to break into the stainless steel or the steel square tube that's welded below this aluminum plate. So there'll be an additional load from that, which is there. Okay, it's drilled through the top of the steel tube. So now 2 inches later, we'll drill through the bottom. And the robot seems to be holding up pretty good. This is a 1/4 inch, 3/16 wall, I think. Or maybe, I think it's 1/8 inch wall, steel tube. Hopefully we don't break this drill bit. There we go. And we broke through the steel tube. And we'll go through and break through to the bottom of the steel tube next. I got safety glasses on, by the way. And we could hit it pretty soon. We'll go up to 5%. There you can see there you can see the drill bit. Okay, so we'll do rapid back to 50%, and I'll do D+. Pull the drill out. And there we have drilled our first corner. So I need to do this 3 more times, basically. Okay, so we've got the code that April wrote loaded into the Kuka controller over there. That's the orange box behind you. And I've got the center drill set. So the first operation for drilling our holes in our table is going to be to do a center drill. which basically just puts a dimple into the surface to define the location for the drill that we're going to do next. And so I think we're set. I'll reset the program. I did check the tool tip offset to the table. So to run the program, I'm going to go and hit reset. And we can actually go to automatic mode too. So I'll flip to automatic. Now I'm going to, there's a start button, a green button on the bottom, and I'll be ready with the emergency stop. Oh, I got to turn the drill on too. A little noisy now. And I'll hit the green button to start, and we'll go back to the home position. So when I pull this trigger again, the program's going to execute because it's at the home position. So let's pull the trigger and I'll be ready to slow it down if need be. And we'll go to our first drill spot. All right, it looks like I need to offset the tool depth a little better. So we'll let it finish this hole, and I'll stop it there. All right, so I stopped the program, and what I did is I basically reset the depth of the center tool to be about 2 millimeters deeper than what it was. You may be able to see, but there's basically just a little nick mark in the plastic coating of this aluminum plate. So now that I've fine-tuned our center drill depth, let's rerun the program and bang this out. Or drill this out, not bang it out, hopefully. Oh, actually I gotta turn on the drill first. Oh, that did it. Working. I slowed it down to 10% because the cable was wobbling a little. I might add a little oil sporadically as well. I don't know however many number of holes, 700 holes, at least pilot holes drilled, and it looks like the pitch looks pretty good. So the next step is to load our actual drill for a M6 threaded hole, and then I will chase all these spot drills with the actual depth that we want. I don't think I'm going to break through the table So we'll probably do like a little more than half an inch, maybe 5/8 of an inch, or like 15 millimeters. This is a 3/4 inch or 19 millimeter thick plate. So let's do that next. All right, so I've updated the toolpath program for the Kuka by doing a find and replace for the original drill center peck height to the actual drill depth, which is approximately 15 millimeters deep into this table. And I've put the drill into the drill bit into the drill chuck and made it the same height as the drill center that we had. So we should be good to go for our correct depth of drilling. And I actually put a GoPro on the side of the hand drill holder, and there's another GoPro on the table. So without further ado, let's finish drilling all of our holes with the actual drill for the tapping. Now I won't be able to tap all of these, but I plan on just selectively tapping the holes that I need as I go moving forward. So let me turn on the drill, and here we go. I already drilled the first hole to make sure. Ooh, that was a little fast. Might do 10%. Yeah, it's cranking right along. I hope we don't wear out the hand drill. Right, so we are at the final stretch. Got all the holes drilled. So let's take off this protective film, which is pretty much delaminated from the WD-40 and the chips, and see how it looks. I guess I need to be strategic to collect all the drill chips as much as possible. And this is the WD-40 has deactivated the adhesive, which may be a good trick, because sometimes this film can be a hassle to get off of cast Blanchard ground aluminum, this Mike 6 that we've got. And here's my scratch that I did, but that's going to be covered up by a robot mount. All right, I think I'm gonna get the shop vac to suck the rest of this up, because this is soft aluminum, and it has a nice Blanchard ground finish, but you can easily scratch it, so which we don't want to do. Okay, so this is the final product. We got what looks to be really straight arrays of mounting holes on our aluminum table, courtesy of the big Kuka robot, Big Yellow. And I think I probably will, maybe with a hand drill, just break the edges of all these drilled holes with a chamfer tool. And then the next step is going to be to get this anodized. I'm going to break the edges with a file as well, and then get it into the clean room, and then we're going to mount 2 robots. The ones I'm going to christen gray and red onto this new table. So thanks for watching. If you like what you see, please consider subscribing and hitting the like button, as well as hitting the little bell icon. And I look forward to seeing you guys around next week, where we will finish off and get the robots loaded onto this table and into the clean room so it can actually start doing work. Thanks for watching, and I'll see you later. Goodbye.